Alrighty. Good morning, everyone. This first webinar we have will be recorded as well, in case any folks uh, aren't able to make it in your team. My name is Eric. I'm the product manager here at Virtual AI. Thank you all for joining our first webinar. So for today's webinar, we're going to be talking about a key challenge that a lot of enterprises are facing working with AI, and that's how to protect your applications without slowing down deployment. So with that, I'm really excited to introduce our speaker, Sanmi Koyejo. He's one of the co-founders here at Virtual AI. So Sanmi will walk through why traditional tools are falling short for AI security, how our guardrail works, and also share some real-world use cases. So with that, I'll pass it over to Sanmi.
Thanks, Eric. Hopefully you can hear and see my slides. Okay,
Yeah, everything's good.
great. Yeah, so looking forward to this, as Eric said, our first webinar, and also I think a lively conversation because I think this is a timely topic. One of the reasons we chose to do this webinar at this time. It seems a great opportunity to be having some of these conversations about AI safety, security, and where guardrails might play a role. So our hope is to be educational in these discussions. Again, we welcome questions. There'll be a Q&A section at the end. So for many of you who are thinking about AI deployments, it's maybe not a surprise, particularly if you chose to join today, that there's a ton of excitement about the opportunity that AI provides. So all of the ways that enterprises, individuals are developing AI systems all the way from chatbots, which is where a lot of the recent excitement started, all the way through to coding, autonomous agents of various kinds, exciting potential enterprise applications. Yet consistently, what we hear back when we talk to enterprises and users is that they have blocks. And so there are reasons, a variety of reasons why, in many cases, going from the excitement of the idea to a real deployment ends up being challenging. And one of the blocks that seems to resonate and be salient over and over again are broadly safety and security issues around generative AI. And so these range all the way from things like jailbreaks and prompt injections to issues around mistakes the models can make, confabulations and hallucinations, issues around data poisoning, issues around privacy leakage, issues around harm that might come from policy violations, either external facing policy or potentially uh, policy within a company in terms of user trust and sort of general reputational risk. Now, some of you might have seen these in the wild, so there are lots of these examples that show up every once in a while. There's one from a couple of years ago now on Air Canada that where someone talking to a chatbot ended up having the chatbots give a reimbursement that wasn't actually sort of approved by the airline. And this became a real case back and forth within the legal system with the outcome that Air Canada needed to essentially effectively comply with the results of the AI system. Again, this shows up in a variety of different places. I'm showing some examples around finance, but I'd say no matter the industry or vertical that you're in, these kinds of issues show up and end up being a blocker to developing systems for applications that, again, we see so much promise and value in. And so from a broad technical frame, there are a couple of directions that help ground how one should think about where the gaps might be in generative AI systems. So one broad bullet of gaps are issues or gaps around safety. So these are harms or problems that can come from standard use. So these are, individuals, customers, stakeholders who are engaging with your system, but will sometimes end up in errors that may have downstream impacts. These things look like issues with mistakes that you could get from models, variations in robustness. So you change the way you ask your question or some changes in the context, and you get an unintended change in the response. Um, from all the way to security issues. So the gap from safety to security is that, again, safety generally covers benign use. Security generally covers explicit adversarial interactions with the model. So these are often bad actors or adversaries, that should be harm, who are looking to break your system in a variety of different ways. And so because of this, prompt the system or engage with the system in such a way that it might lead to negative issues. So some issues here go all the way from things like adversarial robustness, sort of prompt leakage of various kinds, PII leakage, privacy issues, things like that. So these are the kinds of problems that come from, again, adversaries interacting, things like prompt injection to try to break an AI system. And virtual AI has a perspective on how to think about both safety and security. I'll touch on some of this at the end, but I did want to say that we found this a combination of good tooling for detection and then good tooling for mitigation are useful ways to engage in covering the gaps that come from safety and security issues that, again, block development and deployment. So on the detection side, what I mean are evaluation tools, things like large-scale, scalable evaluation, scalable risk detection, adversarial use case simulation, things like that. And so we have some tooling that does this. We'll have some future webinars that cover some of these, the technical and conceptual aspects of detection. Today, I want to focus, though, on mitigation. So in particular, I'm going to talk quite a bit today about some of our work on guardrails, which are one of the tools that we found very effective, but also easy to deploy. So sort of can be deployed using mostly sort of API access to internal generative AI systems, which make them sort of much more turnkey and scalable. And I'll talk through some of our framing and how we think about this problem and some of the successes we've had in trying to deploy these in the real world. Now, if you're here, you might agree with me that, again, this is the time to be thinking about these kinds of issues. Again, there's so much promise from where AI seems to be going on the capability side that is blocked by gaps that we continuously see around safety and security. And these gaps are starting to sort of more continuously couple with real world issues. So financial damage from IP leaks, reputation loss for between companies and customers, compliance failures, risk of things like litigation when these models fail. I'll talk through how we think about AI safety and security and how we think it differs from some of the classic approaches in computing and cloud security that are well established and I think have had such a broad impact in having sort of safer technological interactions and more secure technological interactions. So I'm thinking of cloud, I'm thinking of online, I'm thinking of, again, many of the ways that we use technology. Again, as noted, there's, I think, more urgency in where these gaps can actually lead to, again, real world failures that have real harm, both for stakeholders, but also for enterprises, and something that many of our customers and many of you might be thinking about. We're getting better at understanding what the risk surface is. So within Virtue and in a lot of the research in the community, we're evolving what we call a science of measurement to understand what the edges are of sort of modern generative AI systems. And we're building tooling that helps implement mitigations. Again, guardrails as a salient component of good tooling for implementing mitigations. And I'll, again, this will be the main topic of our discussion today. But there are a variety of additional things that we work on that we think, again, help close the gap, which we'll talk about later. So let's start off talking a bit about maybe classic computing and why existing security tooling we believe doesn't actually close the gap for generative AI systems. So of course, as we're discussing here, a quite well-developed ecosystem for thinking about, again, computing and cloud security. But I think one of the things that we've seen are, while classic computing can again be computing security can be quite capable. Generally, many of the classic computing interventions are implemented via components like rules and other quite scalable technological interventions, but ones that don't seem to meet the need of modern generative AI interactions. Some of the issues here include the fact that generative AI is quite much more flexible in terms of the use cases that people are using or choosing to deploy the systems for. Traditional security depends often on well-defined boundaries, existing rule sets, a good knowledge of the edges of the use cases that you want to build and deploy systems for. In modern generative AI systems, we become much more ambitious in what we want to use the systems for, such that we have quite broad, open-ended, maybe being a bit ambitious in calling it infinite, or at least the symbol infinite. But really, it's much, much broader of a set of use cases that we would like to use the systems for. And so classic approaches like pattern matching and various kinds of rule sets are insufficient for this flexible deployment settings. Some of the other issues that come up in classic computing security are that some of the hallmarks of generative AI is the impact of context. So much of what we do are tied not just to the interactions, but all the information that one pulls in, say, the context that you give when interacting with a chatbot, the data that it might pull from, say, a RAG system. All of the context ends up showing up in the nature of the interaction. Often traditional security systems focus on syntax rather than semantics. And so things like jailbreaks and prompt injections that can exploit the gap between literal rules and sort of deep contextual understanding end up having much more success when we use classic computing systems. In Virtue's work, we also think a lot about, again, evolving and exciting use cases that involve multimodal deployments of systems. And so the gap here is that many of the classic security approaches focus on single channel. So, network, application layer, things like that. As the approaches and deployments of AI systems get much more diverse and multimodal, we see a gap here where, again, classic security approaches are often insufficient to cover what we need from these systems at scale. Talking about scale, there are, of course, issues with difficulty of scaling to all of the ways that AI capabilities have continued to improve. So as mentioned at the beginning, the use cases are expanding. The things that we find via interactions with systems potentially can do are expanding. This makes it difficult, again, to scale up classic, much more narrow framings of security approaches to what the newer world cases are. As an alternative to, say, rule sets, there's, of course, much more involved methods of deploying classic security, using, for instance, deep inspection security tools and other tools that are maybe somewhat more latency, require much more latency, but may be more effective for capturing various kinds of deep issues. And of course, the gap here now is that you're trading off security and performance. So you're getting maybe a bit more visibility into the threats that your system might have by having, say, a human go through specific issues, or having very bespoke sort of deep security and safety sort of checks. But the gap here now is that these don't work at scale in real time. So it makes it difficult for the kinds of deployments that we want to build that require safety and security as users interact with the system in real time. So to this end, one of the approaches that the community has found quite valuable are building tools like AI guardrails. So AI guardrails are specialized safety and security mechanisms that act as a protective layer for AI systems. So their goal is to monitor both inputs and outputs to prevent all kinds of harmful behavior. Similar to, by analogy, things like firewalls for computing systems. They act like firewalls for AI systems, providing real-time protection against various kinds of risks. So specifically, some of the ways that AI guardrails work include monitoring and filtering inputs, so analyzing user prompts, questions, other inputs to detect potentially harmful requests. So being able to detect things like potential jailbreaks, prompt injections, or policy violations. They also act by evaluating and filtering outputs. So they examine AI system responses to ensure that they don't contain harmful or biased or inappropriate content before delivery to users or other stakeholders. And finally, one of the hallmarks of what we're building here are thinking about policy compliance. So this could look like internal policies, again, within corporations or enterprises, alignment with a set of rules that corporations may have, or in various jurisdictions, external compliance. So this will look like regulations in various parts of the world. And so guardrails can be a very useful and effective tool for enforcing alignment of the AI system with policies and ethical guidelines of either of these types. And so unlike traditional security approaches, modern AI guardrails must be able to understand context and understand intent. So being able to apply approaches for mitigation that are much more flexible than rigid rules, which can make them much more effective against things like jailbreaks, sophisticated prompt injections, and other kinds of issues that traditional guardrails and traditional computing security systems can't often solve. So within Virtue, we have a few design principles that have shaped the way that we think through what a guardrail should be. One of them I think is quite important is speed. So as I spoke about at the beginning, often in real deployments, it really matters that your guardrail is not a blocker to sort of real-time deployments of your system. We already know that many generative AI systems have meaningful computing overhead, which leads to latency, which again causes challenges for real-time user interactions. Now you're adding a system in the middle to implement, again, this safety and security protection. But doing this may then, in the worst case, increase your latency by a lot. So, a bad or at least a challenging implementation of this that some other competitors sometimes try are using an AI model as a guardrail, a large-scale existing AI model. And this is great, but has the challenge that now you're paying latency both for the tool that you're really deploying to interact with users, but you're also paying latency for the guardrail function. And this latency, if the model is as big as the sort of actual AI model, which in many existing toolings often are, this latency can be quite high. And so you have issues with being able to implement real-time interactions with your users. One of our key design principles is to make this latency as small as possible while maintaining effectiveness. And so it's important for us to have high detection rates to capture gaps as we see them, as we find them from interactions with systems, both from the user or from the system itself. And as important as this, a system that has 100% detection rate that detects everything as a failure is also not useful. So it really does matter that you detect failures and you correctly pass through good interactions with the system. So you want to have, in technical lingo, low false positive rate. So you want to have a low chance of detecting incorrectly that there is an unsafe interaction with the model. And so this combination of speed and performance really is what matters for having high performance models that do what you want. So allow you to scale and deploy quickly when building AI models. For us, we also think a lot about coverage and flexibility. We want users to have the ability to specialize these systems to the specific use cases and specific threat models that matter most for the industry and their deployments. And so we cover quite a broad range of use cases, vulnerabilities, and risks, but also we allow the ability for users to specify exactly what they want to focus on. And as I'll cover briefly, also the ability to add new risk categories quite flexibly and be able to protect against those. And so to do this, as mentioned, we've developed a guardrail system we call Virtue Guard. So this is our approach to efficient guardrails for safety and security compliance. Some of the hallmarks of our system from both our testing, but also talking to customers, include the fact that we have a real-time system deployment. So we've indexed as a anchor point, you can think of LlamaGuard, which is an open source deployment from Meta, as an example of maybe what may be considered some state of the art in this ecosystem. And what we've shown is our deployments are more than 30 times faster, say on an H100 GPU compared to LlamaGuard. We also find similar kinds of speed improvements compared to, again, many of the other models or approaches that are out there in the ecosystem. As mentioned, we also think it's important for modern deployments to have the ability to be multimodal, so capture all of the ways that users want to build, interact, deploy AI systems. And so we cover text, images, video, audio, and code. And also, we're multilingual, so we have the ability to cover lots of different languages, which again allows easy deployment in international settings, so beyond English speakers. Again, as the capabilities and deployments of these models have begun to expand beyond primarily English settings. We allow for policy following. So again, you can come with your policy and regulation, and we make it easy to convert these into a monitoring framework that can work in real time. And a ton of customization, so allowing for you to specify exactly, again, what you care about the most and make it easy to deploy in real-world settings. We've shown quite meaningful performance improvements, again, compared to many of the existing approaches out there. So just to give a bit more quantitative example of this, I'm showing here a variety of different open source benchmarks that look at various aspects of safety and security. So some of these from OpenAI and many other approaches and data sets. So many of these you can find online if you look it up. And on the vertical axis, each row is a different implementation of some kind of guardrail system. And so we're comparing here some of the work from many of the large foundation model companies, but also open source tools like LlamaGuard, which again implements some of these functionality. And of course, we're happy to share with you detailed numbers, but the key takeaway here, one is on the capability side. So we're showing here a high performance as measured by things like AUC, which is AUPRC, so area under the precision recall curve, which captures, again, how often we make the right detection. We also care, again, as I mentioned briefly, on having a very low false positive rate. So FPR is false positive rate. You want to make sure that you detect the right things, and you very rarely incorrectly state that appropriate interaction is potentially harmful, because again, this is what leads to bad user experience. And finally, we have this relative benchmarking of speed. So all the way on the right-hand side here, where we've shown that we're, significantly faster even than a quite capable system like LlamaGuard, and much, much faster than many of the large foundation model implementations, which have the restriction of, again, being quite large models. So capable in many ways, but having this big model footprint that leads to significant latency. So deployment we've set up so that it's fairly easy. For those of you who are familiar with tools like LlamaGuard, using our tool from sort of API is pretty much a one-line change, where you go from a call to a Llama API to a call to our API. And we also allow for the ability to do on-premise deployment as an alternative to API, depending, again, on the context and being flexible to enterprise needs. In many of our settings, we found that many of our customers are able to implement and deploy these systems quite quickly. So, generally order less than a month. We've been able to go through the piloting, testing and production, refinement, and again, real-time deployment. Again, some of what makes this easy is we spent so much time on the engineering side to make our tooling, again, quite compute efficient and capturing all of what we need to capture in terms of computing safety and security, such that the bottlenecks or the requirements for real world enterprise deployments are, again, quite low. And so we're able to deploy very quickly for many of our customers. To anchor this even more, I'll talk through a couple of customers that we've worked with. So one is Uber, which many of you might know as a rideshare company. And so we worked with them for real-time guardrails for chatbots and dialogue moderation, and being able to show that in looking at, say, driver-passenger chats or various kinds of merchandise-related communications or customer service, we can show that using our guardrail, we can very efficiently identify bad actors. We can ensure compliance to help them avoid fines in various jurisdictions where there might be regulatory overhead, allow them to strengthen trust with their customers, and again, reduce the manual effort in what they might need to implement content moderation and real-world deployments of their systems. And some of the key differentiators, again, are really anchoring on the fact that we have this lightweight, highly efficient system. So it's a minimal computational cost. This multilingual support allows them to support the broad range of users that they have with various languages, and then having high performance and low false positive rates. Another customer is Glean. So Glean works with organizations to implement AI search, enterprise search applications, and various other kinds of internal AI deployments. And with Glean, we've been able to help them secure AI-powered enterprise search against various kinds of harm and protect sensitive company data and communications. And some of the value includes reducing organizational risk and issues from unintended outputs, improving compliance with regulatory requirements, and customized protection for various enterprise research and search contexts. And here, so much of our value proposition, again, ties to the speed, so being fast, having low latency, ability to customize to the search requirements and needs for various enterprises, and then comprehensive threat detection across multiple categories. So I wanted to switch here to a demo, but also we could maybe, if there's some early QA, we can ask some questions. Eric, what do you think? Do we switch to a demo or?
Yeah, there are some early
questions?
questions, but I've answered them via the chat already. So I think
Okay, sounds
can
good.
for now. Yeah.
Okay, I will stop share for a minute and switch over to a demo. So what I'm going to do now is spend a few minutes demoing a GUI version of some of what our tool does, just to give you a feel for what kinds of guardrails we build, and again, our perspectives on some of these issues and what it might mean for your deployments. So here I'm showing first TextGuard Lite. So this is our lightweight text guardrail. And so some of the default policies that we cover include a variety of different issues that go all the way to issues around privacy, to potential jailbreak prompts, and concerns about intellectual property leakage and specialized advice that might come from models. And so you can click here to see some examples where one of the ways people have shown that you can jailbreak models are to role play as a certain individual and try to get the model to allow for unsafe deployment via this kind of jailbreak attack. And so we show here again that the model is able to detect that this is a jailbreak and then give the user the ability to block those kinds of interactions. We also Another example is, say, trying to implement some kind of cyber attack. So you want to use the system to implement a cyber attack, and this is something I might want to block. And so we show, again, that our system is able to detect and make it easy to sort of block these kinds of issues. And so, here's a GUI, but again, this is set up so that it's easy to implement and deploy via API. And at the back end, if you're implementing this as an API, you would get categories and then sort of probabilities. So our detection rates across the various categories so that you can set thresholds and build real deployments. I show another example of, say, a weapon-related kind of query, and then showing our ability to detect and block this. Other examples, so another direction is PII leakage. So again, the concern here is that interactions with systems might lead to PII inadvertently being shared with the generative AI system, which can cause issues and, again, many deployments. So I'm showing an example here of, customizability here looks like being able to pick which kinds of PII one is sensitive to and one wants to detect. And then you get the ability to, via interactions, detect scores for each of the entities and each of their possible, like a probability score around possible PII. So here it detects the individual, the email, credit card number, and then backend, you have the ability to decide which of these you want to allow, disallow, and implement blockers for them. There are other examples that tie to, for instance, medical records, which may be important for certain kinds of medical-facing, say, chatbots, where you want some signals, but you don't want to allow for leaking specific medical examples. Other settings include financial information, so this may be useful for aspects of financial verticals. Other tools include hallucination detection. So here, the goal is to ensure that the model responses are factual. And so we have a backend tool that makes it easy to using both information within deployments within enterprises to check facts, and so detect when models might be potentially making mistakes and hallucinating answers. So again, one of those use cases where you can check potential hallucinations. Finally, I'll just talk briefly about topic guard. So topic guard is set up so that you can flexibly add new topics. So I'm showing here some topics we've added. In conversation, we can show you many more and give you the ability to create new topics. So I've created a dummy topic here, which is supposed to detect any content related to Umbrella. So again, it's, for illustrative purposes as a toy example, but I suppose I decide tomorrow that it's really important for my business never to have anything related to Umbrella in the sort of user interaction. And so you can create this topic, add it, decide on detection thresholds, and then if there is a user interaction that has Umbrella in it, the model will correctly flag here that there's Umbrella. And so this, again, blocks against this potential use case. And I'm showing this as a cartoon, but the point here is, again, this ability to flexibly add new topics and new protections, depending on what one is interested in. As mentioned, our work expands beyond text. So we, of course, also have the ability to detect issues with images. So just like before, you can input your image and we'll give you a response that's with explanations that shows potential issues with this image, which then allows you to construct the topics and construct flexibly the kinds of restrictions that you want in your deployed system. Here I'm showing some fictional non-human images just for illustrative purposes. But here you can see that the system correctly, in a setting where you wouldn't like sexual content, for instance, as part of your deployment, the system correctly detects it and gives an explanation of why it made that detection. There's also the ability to guard videos. So similarly, you can create topics, and again, you can go through some examples. And also we can implement and deploy guardrails for audio as well. So again, the point here is broad coverage, ability to customize significantly to use cases that you might care the most about, and then high performance, both in terms of low latency and high detection ability, and low false positive rates, so low probability of making mistakes in deployment and construction of the system. That's most of what I wanted to cover in the demo. Again, I'll pause here if there are questions we didn't answer, and then maybe switch back to the rest of the conversation. Okay, let me go back to the slides. Okay, so hopefully what I've given you a flavor of is how we think about guardrails, and both in terms of conceptually why we think they're important, some of the gaps in classic computing approaches for engaging this problem, and some of what we think we've developed as, and also we've gotten back from customers as implementations that make it much easier to deploy AI systems with some confidence, because we help remove concerns or reduce concerns around safety and security. So again, some of the key design principles for us are speed, so being able to be as fast as possible so we can work in real time. High coverage, so it allows us to adapt to the broad risk surface that modern AI systems might have, given the broad range of capabilities and deployments and use cases that we were developing and building. And allowing for technical innovation in line with capabilities of the system. So again, what we believe is that the safety and security perspective has to evolve continuously as your system is also evolving and getting more capable. And finally, I've talked a bit about our ability to guardrail around multimodal settings. So beyond text, going to high performance in images and voice and video and many other settings. So our big picture goal here is, again, to make it easy to implement, deploy AI systems with higher confidence. We believe, and we've heard from customers, that having a good safety and security system in place makes it much easier to implement and deploy AI systems faster and safer, because some of the work that we do removes the gaps that you would have to implement and build yourself. Often, again, slower or much more challenging in implementation than what we're able to do being a partner with you. And so some of our principles here and some of maybe the takeaways from here include, if one is starting to build and deploy AI systems, understanding the AI risk exposure. So this includes assessing and potential risks and potential issues with AI deployments. We have tooling that helps you do this, and also happy to have conversations around developing more nuanced perspectives and understanding what the risk surface really looks like. We have tooling that allows you to implement and integrate guardrails early in development. So incorporating safety measures that are lightweight yet effective to make sure you have compliance right from the get-go and make it much easier to implement and deploy. Thinking through what it means to have good multimodal protection. So again, going beyond just text to all the other ways that we want to implement and deploy AI systems. So this includes, again, video, audio, text. We didn't go through code, but I think that's one of the exciting use cases that we're finding being deployed. And one of our perspectives includes guardrails that makes it easier to deploy safe AI code interaction and interactions and deployments. Now, finally, for a good user experience, we really do think it matters that you have both high performance, but also high speed. Your guardrail should not be the bottleneck to a good user experience deployment. And so having fast, safe deployments can be enabled quite well by having fast, safe guardrails. And so this is, again, so much of what we focus our technology on trying to build. I've talked through mostly our guardrail system here today, so that's the goal of this webinar. Over the next few months, we'll have additional webinars where we'll cover a broader set of our sort of safety suites. So this includes not just the guardrail, but also discoverability. So what we call Virtue Red, which is built to give you insight into all of the corners of your system. So having high observability into what your system can do and the potential risk surface. So this gives you information that is helpful for then deciding what perspectives your guardrail should cover. And also is important for thinking through safety compliance. And so we give tooling that makes it easy to, again, have compliance reports that you could then use to understand your vulnerabilities and safety risks. And then we'll also have a future webinar that goes into agentic framework. So thinking through things like MCP and what it looks like when AI systems are deployed with the ability to implement various kinds of tasks and how we're deploying evaluation and guardrails that also makes that, again, much, much faster and more efficient via virtual agents. So we'll mostly stop here. We'll invite you to interact with us. We'll have time for questions here, but also you can request a demo at virtuai.com so we can go through in more detail for your use case some of the work that we're doing and how it could be helpful for you. Okay, so we'll pause here, Eric, and if you have any questions or other things you want to talk about.
That's good. Yeah, I see a couple of questions that have already come in. If you have any more questions, feel free to use the Q&A button on the bottom in Zoom, or you can also raise your hand and we can grant you some mic permission so you can ask live. So one question that somebody had was ChatGPT and similar foundation models already employ moderation and safety filters. How do Virtue AI's guardrails differ in terms of flexibility, granularity, or enterprise level customization?
Yeah, that's an excellent question. And in fact, I think some of the most important parts of our perspectives on foundation model systems really is customizability. So the ability for you to, I think the challenge that we found and many of our customers find for most enterprises interfacing with the large foundation model settings is that the set of perspectives on safety and security and guardrails are mostly what the foundation model company decides is relevant and important, which creates a gap because if you're lucky, then their perspectives match yours, meaning what they think are safety and security issues happen to match what your customers think is important, or happens to match the compliance setting that you're in, the vertical that you're in, and what's important for good compliant interactions in those settings. What many of our customers find, particularly those who are interested in specializing AI systems for their own deployments, is that existing foundation model perspectives are insufficiently flexible to their settings. So this creates a gap. And so our goal is, again, to reduce this gap because we allow for a high amounts of customizability to the specific use case that you're most interested in. The other thing I'll mention is, again, the foundation model companies either pretty much restrict you to using their system. So this creates other issues if, say, you want to fine-tune your own system, or you're looking to combine a variety of different systems. And then, depending on the setting and context, have high latency overhead, as briefly mentioned. And so, again, one of the places where we think this differentiation really matters is when latency is a challenge. And so, again, making the guardrail component of the system low latency for the interaction, we think is a key design principle for good customer-facing experiences.
Great. Yeah, that was a great question. Another one's popped up. As organizations move from static chatbots to autonomous agents, Virtue AI positions its guardrails as both highly performant and semantically aware. Given the rising complexity of risks, how does Virtue Guard maintain a low latency profile without compromising on precision metrics like AUPRC and F1, especially compared to solutions like Llama Guard or OpenAI's internal moderation stack?
Yeah, Excellent and actually impressively detailed question. So that's very cool. So I'll say a couple of things. So one, I think we take very seriously, just as mentioned before, the customization ability. So, we think many of our customers have a good sense of what matters in their context. Of course, we spent lots of time and broadly in this area. Many of us have, over decades of experience in safety and security in AI systems, and so have lots of experience that can help guide connecting your observations from customers or your initial intuitions into sort of actionable safety and security plans. But I think some of what we think is really special is, again, this ability to customize to the context that matters for you. Part of the question was about agent deployments. I'll defer some of the details to our future webinar on agents because I think there's a little bit more to say there because this goes beyond just the sort of interactions with the system, but also system actions. And so what guardrails look like for making sure that, again, system actions don't lead to, say, safety and security risks, various kinds, and sort of agentic deployments. So lots of time to go over that in a lot more detail, but we'll defer to that. But I'll just say here again that we think of our work here on guardrails as the foundation of, again, being able to handle agentic systems. Finally, the question was about sort of, or one of the last part of the question was about sort of scalability and effectiveness. Some of this is where we think we actually have spent a lot of engineering time, and we think our technical differentiation and expertise has given us such an edge. To be able to think about what architectures look like, it's worth emphasizing here that, again, our work are bespoke approaches that we build internally, and again, not using public, say, either open or closed systems. And so having so much experience in this field and sort of so much technical background allows us to think of tooling that scales quite efficiently. And so, some of the secret sauce is exactly to your question and why we think it's so important to be able to engage with this question. And so why we're so excited to provide solutions in this direction.
And the last question that we have so far is, how do companies balance innovation speed with risk management in AI deployments?
Yeah, that's a exciting and I think important question. Again, this balance between the excitement about capabilities and then balancing this with having a good perspective on the risk surface that one might be exposed to with the expansion of possible capabilities. Our perspective on this and where we found quite valuable is both having a strong evaluation perspective and then a strong sort of mitigation perspective, done in such a way that, again, it scales well and it adapts quickly to how the capability surface of your system is evolving in your deployments. And so what I mean by this, and again, some of what we'll have a chance to talk through in future discussions, is having good observability into what the AI system might do and also where the risk surfaces might lie. We think, again, makes it easier to just, again, have good predictability in what to expect in real world settings. We do this via some of our scalable evaluation suites, so Virtue Red, as we've talked about briefly, which again allows for high observability around what are the corners of real deployments and what should I expect when getting my system into the real world in this way. So we think this is a way to de-risk development and deployments because, again, you have a good handle on what you should expect to see via a strong evaluation infrastructure, which you could do with us. And we're excited to help partner and help you build this. The second part of this is, again, having good mitigation strategies. And again, these things work together. So observability tells you where the failure cases might be, gives you signals about what you should expect, gives you signals about what you might need protection against. And then the guardrails build defenses to help you mitigate those issues. And so our goal is to build such a sort of easy to implement and deploy technological infrastructure around safety and security such that you don't have like this, you essentially don't have to think about it is the best aspirational goal that we have. So we want to make this as easy as possible for your deployments. And we think we can do this by having a quite strong sort of technical tool set, but also important expertise and leadership in this area such that we can give you good signals on, again, both what to expect, so what the vulnerability of a system might be, and then good protection mechanisms so you can reduce the risk surface in your deployments.
Great. Those are all the questions that we had today. Was there anything else that you wanted to mention, Sammy, before we wrap up?
Um, no, I think this was a fun. Thanks for all the questions and interactions. There may be additional things to say and how we think about some of the science around uh, both evaluation tooling. Again, as mentioned, we'll leave that for some future webinars where we'll go into some of the details of that and how those interact or play well with our guardrail. And then we'll talk a bit about, again, agentic systems and some of the unique challenges that show up there and how the broad ecosystem ends up working together to sort of allow for effective scalable deployments. But otherwise, I think we covered most of what I was hoping to cover. Hopefully for those listening, you found some of this informative and some of the sort of hopefully maybe for those who are not as aware of some of the space, some of the technical tooling and some of the words people use are maybe a bit clearer. We're always happy to follow up offline and go into more detail and talk through how we think our infrastructure might help you deploy your AI systems more quickly and more effectively. But yeah, it was great to have this conversation and great to hear all the questions that people had.
Yeah, 100%. And if anyone wants to set up a demo or want to learn a little bit more, you just go to virtuai.com and there'll be a button to request a demo with us. And like somebody mentioned, we'll be having a lot more webinars. This is our very first one, so please let us know how we did. I think there'll be a little feedback survey afterwards automatically sent. But yeah, I appreciate you all taking time out of your day and hope you all have a good one.
Yeah, thank you.
All right, see y'all.